I'm going to do one example that will help you on the homework and might give anybody who missed last class a bit of help. I'm going to do a problem that's very similar to the one assigned for homework. It's number 25. And it says, use implicit differentiation to find an equation of the tangent line to this curve at some point. So the curve is y sine 2x equals x cos 2y. And the point in question is pi over 2, pi over 4. Now, this is chapter 3.5. Notice this is a mashed up equation where the y terms are mixed with the x terms. The y's are inside of functions, and this is not a nice clean function of this design where it's just y is some function of x. Now y is a function of x, but it's all twisted together in a knot, and I don't see an easy way to put it into a form y equals. So we use a term called implicit differentiation, and I say that's just what the hell differentiation. So it's not nice and tidy, but we just differentiate it anyways. And let's just ask the question why we're differentiating it. Because it's asking for a tangent line to this curve at this point. And let's remember, tangents are lines. Y equals mx plus b. That's the equation of a line. And if I need to find a tangent, then I need to know a slope. And a slope is a derivative. The slope is a derivative. So we need to find the derivative so we can find y prime, so we can find the slope. So we need to take the derivative of this wacky function. And if you want to know what this function looks like, type it into Wolfram Alpha and just type plot and type exactly this equation. This is a tangled equation, yet Wolfram Alpha will still plot this, and the part of it that we're interested in, it's actually a pretty complicated plot, but the part that we're interested, sort of, it has some kind of wavy form, non-standard wavy form, and I think the point that they're telling us is pi over 2, pi over 4, it's somewhere on one of these points. But this just gives you a sense. Wolfram Alpha will give you a sense of the kind of graph you're looking at, even if it's not of a standard form. So, point is, we need to find the tangent line, we need the slope. Slope is equal to a derivative. So let's just plunge ahead and take the derivative of this. And implicit differentiation means just go for it. So, taking the derivative of the whole function means that I'm taking the derivative of each side. So I'm taking the derivative of that, and that's going to be equal to the derivative on the other side. Most people probably won't even bother writing this part out. Okay, this looks like a product of two functions. So I'm going to use the product rule here. And the product rule says the derivative of the first function, the derivative of y is y prime, leaving the second function alone, plus the derivative of the second function, which is the derivative of sine 2x, leaving the first function alone. Now I haven't solved that, but at least I've set it up. This is a product rule as well. There's two functions here. There's an x and a trig function. Product rule says derivative of the first function, which is 1, times the second function, plus the derivative of the second function leaving the first function alone. Okay, I have derivatives of trig functions with nested functions inside. This is chain rule time. Y prime sine 2x plus y. Derivative of sine is cos, so I'm going to use the chain rule here. Sine cos of 2x, leave the derivative of sine is cos, and now I need to multiply that by the derivative of the internal function. Derivative of 2x is 2. Cos 2y plus x. Chain rule here again. I have a trig function of an internal function. The internal function is 2y. Derivative of cos is negative sine, and the derivative of the internal function is 2, and the derivative of y is y prime. Okay, I need to try to isolate for y prime. I have a y prime way over here, and I have a y prime over here. There's a negative sign here, so I'm going to try to bring these both to the same side. So I'm going to add, I'm going to add x sine, I'm just going to add this term to both sides, whatever it's called. I'm adding it to both sides. The effect is that this term disappears from this side and appears on this side. Y prime sine 2x plus x sine 2y times 2y prime plus y cos 2x. There's a times 2 in here, which I can do a better job of arranging. Cos 2y. So I want to isolate the y primes together, so the first thing I want to do is take this term and minus it from both sides. That will bring it from the left, and it'll appear on the right as a negative. And here I can clean this up a bit by bringing y prime out of both of these terms. Y prime is a common factor, which I can factor out. Y prime times the sine of 2x plus 2x sine of 2y is equal to cos of 2y minus 2y cos 2x. Now I have y prime by itself. I can divide each side by this long term and say y prime is equal to cos 2y minus 2y cos 2x divided by sine 2x plus 2x sine 2y